Okay,
Ready to
let's
go.
start.
Hello, so I'm Robert Noe,
I'm Byron Zaharico. Alex Garrity.
Paul Holder.
Justin Neitzel.
and we are the Weg people, and we are working with Wegmans to deliver the Mobile Supply Chain Visibility Project. All right, so real quick, we just have a brief agenda. We're going to go over the project, the problem statement, and the product description. We're going to move on to talking a bit about our process for approaching this project, and then we're going to show you a brief demo of what we have so far. All right, envision this. It's 9 a.m., you're hungry, and you want your favorite cereal, and you go to the store, and it's gone. I feel like that's pretty soul-crushing. It's actually a real problem. This image comes from a news report about a particular company, not Wegmans, who had been receiving some controversy for their very empty shelves. So this is, in fact, a pretty real problem. So what's causing these out-of-product situations or out-of-stock situations is sort of at the heart of what we're trying to solve. This could be caused by a variety of sources along the supply chain. It could be in-store, it could be a natural disaster impacting whether or not we can deliver something on time, a lot of stuff. The impact that it does have on our customers is going to be very negative, so it's just kind of a given. What else do we have? Yeah, and so we want to understand how we can address shelves in an effective manner and how we can provide that visibility to people who can address that, such as executives at Wegmans. All right, so the basic description of our product is a mobile app that's targeting iOS and Android devices. It essentially allows you to scan a product's barcode or enter an identifying code like a UPC, and it will display some concise and actionable information based on what you're giving it. So, I want to look up the last time that some popcorn was delivered because I love popcorn, and maybe the shelf is looking a little empty. Are we going to get a new delivery soon? That's something that you should be able to do with this application.
So for our project, process was pretty important to us. We wanted to be intentional with that. So we chose to use Scrum, and we could sit here explaining what Scrum is to you guys, but I'm fairly certain most of you have been in a class or two that mentioned it. So instead we're going to kind of show you why we chose Scrum, and then also the different parts that we kind of modified it to best fit our project.
So the first thing related to Scrum about why we chose it is the non-functional requirements and the quality attributes. And the first thing on this list would be that we have to eventually give this project over to Wegmans at the end of the year here. So it has to be maintainable. They have to be able to maintain it. So we had to use their technologies and tools such as C# and Azure. Something else, we had to have traceable units of development work, so that fit very well into user stories and into Scrum. We need to be responsive, so if something comes up and if something that we have created isn't quite right, we need to be able to change that very quickly. So sprints and being able to change that. And business logic has to be server-side, so all of that will be shown in our architecture later on. Our mobile application has to run on both Android and iOS. However, we're mainly going to be focusing primarily on iOS because that's what most executives have. And finally, we have to use Azure for deployment.
So before we officially started using Scrum, we started trying to basically mine functional requirements out of our sponsors. The first time they met with us, they kind of had a general idea of what their final product was, but they didn't know how they wanted to get there. So what we did is we slowly iterated on a domain model to kind of understand what's going on with their project. So because the main purpose of our project is to provide visibility to a business interaction, it's imperative for us to understand those business interactions. So the domain model helped us understand what was going on, and it helped us tease out those requirements. We then used that domain model to build a whatever these are called, I'm blanking on the name of them, wireframes, which we would then continually iterate on them, just like we did with our domain model, and those wireframes would eventually be able to generate user stories. And now you might be thinking, wait a minute, why are we talking about this stuff when we were talking about justifying Scrum? So we get to that because before we started using Scrum, we had a meeting on locations on location at a Wegmans store to kind of see how things were doing. We later had a second meeting at Wegmans HQ. So while we were doing this process of this domain model, we kind of identified this key target user. It was the Wegmans executive. So this Wegmans executive is, they care a lot about when things are out of stock. Wegmans cares very much about their reputation, and empty shelves affect that reputation. They are primarily using an iOS device, but there are some executives who are known to use Android. They generally want to know what's wrong, and that's it. They don't need extra information, and they want to know what can be done to solve the problem if it hasn't already been solved immediately. Aside from them, we also had a secondary user, which were like regional store managers and lower level people, but we were primarily targeting executives. So because we developed this really like solid target user, and Scrum is kind of like user-centric, it's like, so we had a target user to help us establish a very clear-cut UI, and then this user also helped us generate user stories specified around a single type of use case, which was an executive trying to figure out why something was out of stock.
So next up is our general process, and before we actually really started with Scrum, we had a bit of a before period, Sprint 0. This is when we dealt with a lot of things that had to do with stuff that you really can't fit cleanly into sprints. So first thing that we worked on was kind of high-level architecture. Right here you can see that we don't have direct access to Wegmans data sources, so they exposed a API that we can use, and we connect to that with a component in our controller layer called the data adapter. This data adapter adapts and aggregates the data from the Wegmans API and changes it a little bit to be more of what we're expecting. Also connected to this data adapter is our mocked data. At the moment, Wegmans doesn't have all of the data we need coming in from this API, so we have to create mock data in order to be able to currently work on that without having to stop. That data gets sent to the mobile API, which is what our Vue, iOS, Android connects to on the back end. This is where all of our business logic is, where any kind of functions changing the data or doing anything to the data happens. And from that just connects to the Vue, which is our iOS, Android app, which contains two separate areas, which is the logic and kind of the UI forms. And you can kind of see it here, but we'll go into a little bit more detail right here. The data flow. The mobile app will request certain info based on the UPC that the user sends in the store that it's in. It'll go to the mobile API, which will contact the data adapter. The data adapter knows where that data is, so it'll create a data source that will then loop through a bunch of API calls to Wegmans and get a bunch of responses from them. It'll aggregate it and return all that data to the mobile API, and then that mobile API will return the requested data back to the mobile app.
All right, so since this is a very product-centric project, some early UI exploration was very essential to us. So we started with some sketches and we iterated on those using some wireframes and an early prototype using a tool called Figma. And then from there we continued to iterate on our wireframes and sort of increasing the breadth and fidelity of those deliverables. And we regularly presented these to our sponsors for validation along the way, both on-site and during our weekly meetings. So an important part of the UI is how the application flows. And we started out with a very simple app flow, like I start my device, I want to be able to see this information, how do I get along there? And we expand it a little, looking to the future. Maybe there's some user validation maybe you have to consider choosing the store that I'm at. For our wireframes, we wanted to start off with one of the core requirements, which was product data, and we wanted to understand what product data we're showing and how we're showing it. So there's a lot of figuring out what the data is and how we want it to look, and what's important, what should be grouped together, and that's very core to our early wireframe deliverables. There were some key requirements that we also got out of this, such as the fact that sponsors really need this data to be here right now. They don't want to scroll through a bunch of unrelated information. And so we sort of continue to iterate on this. You don't have to really read these. This is just giving you an idea of the amount of work that we did upfront with wireframes. For our prototype, we wanted to deliver something that was sort of tangible early on, so we used a tool called Figma, which is just a prototyping tool that allows you to deploy to your mobile device. It was just something for them to play around with and provide early feedback for. So it's not targeting any executives, but it's something that we can get early feedback with. And it allowed us to play with some colors and element sizing and see what works for us on a mobile device. And so this is just an example of what we were able to make with Figma. Now, as for later iterations with the wireframes, we sort of expanded our breadth by looking into different screens of the mobile app. We wanted to iterate on what we already had there. Maybe some data we don't need to show to them, maybe some data doesn't really exist, maybe it was a misunderstood requirement early on, or maybe some data is really important and we need to highlight that in a more clear way. And so you sort of see that as we're working on these wireframes over time, we're expanding the breadth, we're playing with certain visual elements, and this is sort of where we're at currently. You can see like a significant change would be the toolbar at the top of the page. It's a little small, but things are changing over and over, and it's something that we'll continue to work on with our sponsors.
So as we're working and iterating on the design and requirements process, we're also figuring out our development process, how we're going to do that most effectively. So there was just kind of a handful of things we set in stone so that we'll make sure we do this to operate most efficiently. So like probably most everyone in the room, we're using Git, we're using pull requests, but because we're going first, we get to say that without sounding repetitive. We also did document pull requests, basically the same process you would go through with the code PR, but also for all our documentation, not just code, but also like requirements doc, the domain model, stuff like that. We're using Azure DevOps for all of our DevOps related things. So we're storing our code in their Git repos. We're using their boards, which is basically like Jira if you've used that, to track user stories, user tickets, that kind of thing. Nice, clean process to keep track of all of that. And we're also using their pipelines, which has probably been the coolest feature from that, where we get to, it's kind of like Jenkins or TeamCity, something like that, where you, every time we check in our code to the dev branch, it merges it straight into our deployment process and deploys it, tests it, makes sure everything's working, which just gives us a nice continuous integration to keep us flowing smoothly. We're using Azure. This was a non-functional requirement by Wegmans, but has worked well for us. Specifically, we're using their app services, which is their pre-built boxes that let you deploy your code straight to it without much configuration. It limits us a little bit in terms of customizability, but the uptime is much better, and we don't have to worry about it crashing, because if it crashes, it restarts itself. And for our branching strategy, pretty industry standard branching strategy. We have a master branch, dev branch. Anytime we have a story, we branch off of dev, go back into dev. And so dev is what we always have hosted in our pre-prod environment. And then every time we do a release, we merge dev into master and send that to prod.
Next, we're going to go over sort of our testing process. So first, some of the tools we used were XUnit and Fake It Easy, and these sort of helped us mock some things when we were creating unit tests and also run those tests automatically on the CI. And then we also wanted to mock out some of our services, so we were really focusing on data flow through the application. So we have some services that get the data from Wegmans API and send it to the mobile app, so we wanted to create some mocks of those so we could test on just the mobile app, and then also be able to test with the actual services. So this sort of goes over to why we focused on integration tests over unit tests. We have unit tests testing all of our different units, but we didn't have a lot of complex business logic. It was more about getting the data from Wegmans through our services to the mobile API. So we really wanted to focus on making sure that the integration was there. So now, since we have a lot of the integration set up and ready and we have the main user flow done, we want to switch our focus over to acceptance testing, because based on our user, they need simple data and they want it to be able to be very usable. Otherwise, it won't have a high adoption rate. So we've been iterating over our wireframes, but we want to begin doing user testing and then also leveraging some of Xamarin's acceptance testing frameworks to make sure that our UI is very usable. Next, some of the metrics we've been collecting to help our process. So initially we had 3 metrics that we decided we wanted to track, and then partway through we discovered some problem areas, so we decided to track some additional metrics to help us solve some of those areas. So the first thing we were tracking was just our time spent on any work over the week. So we have it color-coded, so that way each team member can sort of see how much effort everyone else has been putting in and can keep each other accountable. We've also been estimating how much work we'll have each week and then comparing that to how much work we actually do. So as you can see here, we're not always great with our estimates, but this helps us know that, oh, maybe we assigned too much work. Oh, maybe we thought this was going to take longer. So then when we're planning our next sprint, we have a better idea of what we should be assigned to that sprint. And then going along with that, we've also been tracking our story velocity. And this really helped us. As you can see here, we have a backlog bar. So we've really been going over this a lot with our sponsors, saying this is where we know we're going to get to. Is there anything below this bar that you think we should prioritize above it? And is there anything above it that you think maybe should be swapped out for something below it? And then these were some additional metrics that we decided to track. So we noticed that we were spending a lot of time blocking each other, and that's what was really stopping us from making progress during sprints. So we wanted to track how long we were blocking each other and what exactly is causing those blockers. And we found that pull requests were a big problem of this blockers, so we weren't really responding to each other's pull requests fast enough to get things merged and onto the next story. So what we decided to do was make sure that each pull request is being interacted with at least once a day. And then now we have a demo to show you.
Display automatically? Or do you, there's a little button there.
Yeah.
Okay, sweet. So this is just a very, very early look at our in-progress app. So you start off with essentially selecting the store location that you're going to pull data from. You have the option to either scan a barcode or enter an identifying product code, or UPC. So here I decided I want to look into maybe the Italian marinade at Wegmans, and I'm shown just a very basic overview of data right now. The data that you're seeing is actually mocked up right now, but that's essentially going to explain why you're entering UPC codes 1 and 2 at this point. 3 actually. Yeah, so this is just a very basic overview of our app in its current state. That's all. I think the next slide is questions. All right.
You mentioned that there was some data that might be shown to the end user and some data that might not be. Could you give some examples of that?
Can we give examples? I don't remember mentioning.
There's a lot of data that comes from the Way API that we really don't use at this point. Like, I can tell you what we do use, but
I do think I have a response. I think I know what you're getting at. Yes. So there is a lot of data that's associated with products that's beyond the scope of not just the API, but what the executives might want to see. There are systems for accessing that, but those systems are not geared towards a semi-technical user who wants to understand, hey, this product it looks out of stock. You know, why is that happening? So I can't give you an exact data point, but it's sort of like the way that it's presented to the user, if that makes sense to you.
Yeah.
So you have this, you're basically trying to figure out whether or not why a product is not, why it's not on the shelf. In terms of like a progress bar of where you are in the whole overall project, right now you have the mock-ups and the wireframes and whatnot, but where was the end goal of this semester and how close did you get to it?
So the end goal of this semester was to have basically an MVP where we could scan something and have that data appear with a reason for why it's missing. And we do have that. That demo we just walked through, it looks not fantastic right now. We haven't done any sort of like UI work on it beyond just making it work. But it goes to hits their servers, gets the data, downloads it, and presents it to the user.
The reason we're using a lot of mock data is a lot of the data that's like really important to us, we're still having trouble retrieving from Wegmans, and we're like actively working with our sponsors to resolve those issues. But we're right up against the end of semester, so we thought it would be better to get everything working with mock data for this presentation than risk some sort of mess up when we're trying to use live data.
You all have put a lot of focus, I would say, into designing and talking with your sponsors about the wireframes that you've created. What would you say is the most unexpected change that you had to make to your wireframe after a discussion with your sponsors?
I can start.
Yeah.
I personally, they asked us to remove a lot of information we were showing, and we were like, they don't need to know that. And I was kind of surprised how, out of all the information, they were like, here, we'll have this for you eventually. How much they actually wanted shown on the front end is like probably 10% of what we have available to us.
With regards to the wireframes specifically, the one thing that I think off the top of my head, there were initially a few fields that sort of took up the span of the page, and we ended up removing some of them because they weren't identified as super necessary. One of the data points that I could point out, if you actually look through the slides, is that there's an image at the top, which initially we had there. We followed up, and it wasn't a higher priority thing. It's available to us through the API, but we decided that since it's a lower priority requirement to display an image on our product screen, we are not going to do that right away. You know, that might be something that we can reach with a stretch goal if it's nice, and if the data's there, then we might be able to show it. But it's sort of just a requirement that we're like, oh, okay, maybe we don't have to focus on this right away.
It all kind of relates to what the executives want. Do they want all this data? Not really. They want immediate actionable data that they really care about, and then they can go in and tell somebody, hey, this needs to go and get fixed.
All right, no other questions? Let's thank the team.
So we're the
senior project team doing an RIT sustainability dashboard. Our team name is Net Zero, and I'm Nicholas Baxter.
I'm Sean Lavorse.
I'm Sergio Molina.
I'm Henry Zimmerman.
And we're advised by Tom Ruckemeyer. So just for an agenda for today, first we're going to do our project synopsis, then our sponsors and stakeholders, requirement solicitation, our initial design, including a domain model and architecture diagram, the process we chose, why we chose it, its overview and the metrics we chose to go along with it, our implementation and current status of the project, and then a mid-year reflection. So for our project domain and customer needs, we have the sustainability dashboard. It will be a web-based platform allowing the RIT community and general public to see the energy production and consumption of buildings, solar arrays, wind turbines, etc. at RIT. The information will be tracked in 15-minute intervals and displayed in the dashboard with hourly updates to give the users pretty granular information. This will allow them to view trends of that production and consumption, export the raw data for further analysis on their own if they would like, and identify areas of improvement for sustainability at RIT.
So a project like this spans across 3 different organizations within RIT, so it's important to understand the sponsors and the stakeholders to know who's kind of responsible for what and where the expertise lies for whatever we need to get done. So Golisano's Institute for Sustainability is our sponsors, and so our connection point there has been with Enid Cardinal, who is here today. And we also have Christopher Piggott, who is a specialist with FMS's systems, who is part of the Institute for Sustainability and understands the domain that we're working with, as well as the technology that we're going to need to be using. Additionally, we've been working with RIT's Facilities Management Services, FMS. So we've been working with Mike Weiss, who is responsible for the team that controls the data that we need to get for this dashboard. So we need to be working with this team to get the data from their system into our system. Specifically, we've been working with Mike Vink, who is in charge of a tool, Web Control, which is where the data actually gets stored and where it's going to be exported from. And Dave Harris, who is actually above both of these guys, and he really knows the domain of RIT's electrical setup and how everything happens and all the vocabulary that we need to know for that. We've also been working with RIT's Information Technology Services to get our environment set up. So Kim Sowers is responsible for ITS's projects team, and she's redirected us to Dave Pecora, who's the manager at ITS Data Management, and Rick Miles, who is the manager of ITS Enterprise Web Apps. And these guys have been helping us figure out what tools would be appropriate for this project and what tools ITS has available for us that we can use to figure out how are all the pieces of this project going to work together to actually make the final product. And finally, one of the important stakeholders would be RIT's community, given that they're the people that are going to be using this project and the ones who are benefiting from it. So for requirements solicitation, we had our first meeting with Enid back in August, and at this meeting we really wanted to get an understanding of the domain. None of us have really worked in this side of things before, so we really need to understand what were the desired features that were needed. We also wanted to review the project proposal just to make sure that any changes that might have happened between the writing of the proposal and the start of this project were ironed out. We also needed to gather our resources. So at this meeting, we had people from ITS and FMS available for us. So we were able to figure out who actually had the specific knowledge that we needed, as well as figuring out what tools were relevant to the project. And at this meeting, we kind of discussed sponsor expectations to figure out what they wanted us to get done over the course of the year and maybe get an idea of what we could accomplish in the year. So we returned from this meeting. We compiled an initial list of requirements that came up with some questions just to sort of elaborate further, and then we went into our next meeting. At this meeting, we presented the initial requirements, got some feedback of things that we had been missing out in this list or things that we had wrong from the requirements. And so sort of get more confirmation about what exactly needs to happen. We then asked questions just to sort of clarify things, sort of get an idea of how we could get started on this project. And then we sort of addressed scope for this year because it's actually, the initial proposal had a lot more things beyond what we actually are going to be able to get accomplished. With things like water data and waste disposal data were out of scope for this year, so we addressed those concerns early. And then we had meetings with FMS to sort of understand the data pipeline process, how that's going to happen. So we wanted to understand how is the electricity data set up, what does it mean, what is RIT's set up for everything. So that's where we met with Dave Harris, and he gave us a very, very overarching overview of how RIT's electricity works. And then we sort of learned how does that data go from all the meters across RIT's campus into some central spot, and then how we can get data out of that spot to our system. From this, we formulated a simple domain model.
As Sean just mentioned, we made our domain model in a way that it encompasses all the scope, but then highlighted what we're doing and what we're not using dash lines. So out of scope, as you mentioned, natural gas, water, and solid waste. For in-scope, we're doing electrical data. Our producers for electrical data are the fuel cells, the wind turbines, and the solar arrays. There's a few solar arrays on top of different buildings around campus, a large array on top of the Sustainability Institute, and then an array on the southeast side of campus, with another one being in construction. And then our consumers are the buildings and the building clusters. Building clusters are either academic or residential buildings, two separate clusters to compare them. And then the main aspect of our dashboards are the metrics, which are produced from those electricity producers and consumers. That dashboard will display those metrics through graphs and visualizations. Some of those visualizations are going to be things to make the numbers easier to understand. Some are going to be in kilowatt hours, while others might be in the cost of a cheeseburger or the cost of a student tuition. And the general public is going to be able to view those, even the RIT community. And the RIT community is going to have the additional option to export that data in CSV files if they want to do more analytics themselves. An additional point is we're going to store historical weather data so they can track the correlation between different amounts of electricity produced and consumed depending on the current weather for that day.
So to begin our architectural design, we first had to identify the actors from the domain model. We wanted our design to focus around extensibility and reliability, because in future iterations of the project, we're going to include other resources such as water, natural gas, and waste, alongside electricity. And so we agreed on the extract, transform, and load procedure in order to prepare our data for analysis. So this is our high-level component design. And so FMS is going to be providing us a zip file every hour. And in this zip file, it contains CSV files of data from the meters that we're going to analyze. There's also an index.json file which is used to reference the location of each zip file. And so the zip file is going to be located in an FMS server, and we're going to use a UC4 job scheduler in order to extract that zip file and process the data inside of it. Once we process the data, it's going to be stored in our Maria database, which is provided by ITS. And with this data, we will be able to provide visualizations on our web environment using Tableau, which is a business intelligence software. And in the browser client, the administration would be able to make any edits or changes to our web environment.
So for our development process, we decided on Kanban. Kanban's main thing is managing the creation of products with an emphasis on the visualization of the process itself and the work going through that process. We chose that in hopes of limiting the amount of work in progress we had, because we find that when we have multiple things in progress, we're less efficient. And Kanban does that by being able to see if a card or multiple cards are all being in the swim lane of in progress. Swim lanes being the different states a card could be in, whether it's to do, in progress, in review, or done. And for us, we have an ITS provided GitLab, so they can see it. ENID can also see it, which contains our swim lanes and our cards. Some of the metrics we chose for this first cycle is time spent in progress, to find out if we're being inefficient, if we're being blocked by something we didn't recognize, or if the story is too big or the card is too big and we need to decompose it into more cards. Development time versus meeting time. We wanted this ratio because we are working with so many different groups. For this first semester, we've seen a very, very large emphasis on meeting times with not as much on development time to clearly understand the project and clearly understand how people want it to be done. And in the future, once the ETL process is completed, we're going to have ETL failures to find the availability and reliability of our system.
So for the sake of maintainability by ITS staff in the long term, we were sort of given a set of tools to work with. So for the ingestion and web server, we're going to be using Java. The database will be using MariaDB. The whole thing is hosted on a Red Hat Enterprise Linux virtual machine. And the tasks that will be causing the import process to occur is scheduled via UC4. Visualizations will be created by Tableau, which is just a business intelligence software that the school has a subscription to. And when we eventually get to the front end, we are likely to use Angular.
So after we finally ironed out how the data would get from FMS's system to our system, and we wanted to start designing our ETL process, we needed to sort of come up with a schema so that we could define how the data would go from the shape it is in FMS's server to the shape it would be on our MariaDB server. This would allow us, once we're in Tableau, to just easily connect to the MariaDB server and just create the visualizations without too much work. So we came up with an initial design schema with an ER diagram and presented it to ITS to get some feedback. And fortunately, they have the experience and the knowledge, being that they're the ones that have used MariaDB and Tableau, and they've had years of experience in the field, so they were able to provide us with feedback about how to improve the schema. So this is the final schema we decided on. So we decided that the best way to store all the data would be one time series table, and then that time series would keep track of the data value and as well as which meter gave us that value. The meters would keep track of what type of data it is, so electrical for this iteration, but in the future, water, waste data, and anything else could be stored as a meter. And then the meters also keep track of which building it is. On top of the time series data, we're also keeping track of conversion factors, so things like how much did however many kilowatt hours cost on this day would be a conversion factor, converting electricity to dollars. So we're storing those conversion factors, the date range that it was applied, as well as a string value associated with what that is a human readable name for it.
All right. So we initially wrote just a prototype implementation of this ETL process, the whole importing of data into the database in Rust. We did that because it was pretty easy to prototype in, and it does all the required tasks required by that. So it reads the data from the zip file, it transforms it into some format that's usable by the database, and then it stores it in the database. Currently, we're in the process of porting that to Java, so we currently have the sections where it reads the data and transforms it, but the actual storing it into the database is not yet complete. In addition to that, we're likely going to need to add some filtering or at least expansion of data given the actual data source that we're given, so it can actually be usable later when we're actually creating visualizations using it. So the current status of the project is that we have our requirements completed. We have the schema set up and approved. The ETL process is prototyped, and we're working on the long-term ETL process. We are where we're at right now is because this is a new project. We just started this year. There's a whole lot of intergroup communication that we need to iron out, and it's taken quite a while to get requirements with some changes that have occurred throughout. And we plan for the next semester to be much more on the implementation side, considering how thus far we've spent most of the time just working with requirement solicitation. So we intend to finish the ETL program. We want to integrate that database with Tableau. We want to create our charts and visualizations using Tableau. We're going to build a website that will be served and will be able to show those charts. And then in addition to that, we'll need an admin panel to manage that and have then the export tool for exporting the CSVs for use by RIT staff.
So challenges encountered, we found a couple of them. I think you've all seen the picture on the right there. Basically, that's the biggest thing we found so far, is that our stakeholders span multiple organizations, which leads to multiple different understandings or expectations of the project, which leads to our overlapping domain knowledge with holes in it. So some of our stakeholders are very knowledgeable on the clean and renewable energy side, where others are very knowledgeable on the physical meters and how they measure and how we access that data, which leads to some miscommunications or some assumptions on how something should be implemented or can be implemented. Another thing we found is that ITS internal processes take a long time. It took 9 weeks for our database VM to get set up and delivered to us, and 11 weeks for the server VMs. The server VM was expected to be one way and then was changed due to an internal decision, which then was updated to us. These were parallel processes. We only delayed 9 weeks in that aspect. And then, as I mentioned, FMS stakeholders each have and hopefully will be had different expectations. So this is when we discovered it in week 12, and we have a meeting this Thursday to actually solidify that one concrete understanding.
So some of the successes our team found was that we were able to maintain a high level of motivation throughout the term. And through our understanding of the domain, we were able to create designs that required little feedback. And also, we had great team dynamics. In the beginning of the semester, when we formed our teams, we identified our roles in our team quickly, and we were able to normalize those roles and begin doing work. In terms of area for improvement, next semester we plan on using more methods of communication. So there are instances where we would Slack someone but not follow up with an email, or vice versa, and that would end up in a delay in setting up a meeting or getting a question answered. So we plan on using both methods of communication. We also want to become more proactive next semester. So next semester we plan on, if we send out a meeting invite, we plan on following up if we don't hear back within a certain amount of time. This semester we were a bit laid back. We held back on following up on our stakeholders in terms of setting up meetings. And also, we want to make sure that next semester, at the end of every meeting we have, all of our team is on the same level of understanding and on the takeaways what we got and what work we need to get done from the meeting.
Questions?
Questions?
Yeah?
Do you guys have a plan for testing?
We haven't really defined too much of like official unit tests or much, but we have our requirements that we're going to develop acceptance tests from.
What were some of the major risks that you encountered in your mitigation process for those?
So one of the major ones is week 3, it was determined that we weren't going to be able to use the data in the database that was already existing. They determined it was too fragile for us to touch, so we ended up having to change our scope to expand and build our own database. We mitigated that by doing local installs of our MariaDB and basically calculating how many rows we've had in that database to see how long latency requests would be in terms of different queries the user might run. That was the biggest one, and then obviously our miscommunication and resulting in different expectations was the other big one.
Other risk would have been that it took so long for ITS to get our environment set up. We actually mitigated that by switching over to using local environments, so setting up MariaDB on our own machine and sort of starting the ETL process there instead of waiting until we had a dev environment to do it.
I'm interested in hearing about your design for implementing technology. For the ETL stuff that you're currently writing, have you looked into existing tools that already exist?
Those are mostly determined by ITS. They're going to be maintaining this project after we finish.
How could you have, looking back, how could you have foreseen the problems that you did have earlier? I'm thinking maybe from workers' requirements and conflicting things of importance in your stakeholders. How could you have identified that sooner and taken an action to mitigate that sooner?
Well, so the change in requirements, we did kind of expect that tends to happen with most software projects. So we had kind of tried to come up with designs that would be flexible in case we needed to add a component here, add a component there. So you saw our design is very linear. So the data kind of goes in one end, comes out the other. So we kind of have this continuous flow where we can insert things or remove things as needed. As for the miscommunication and the expectations that FMS had, that probably should have been sort of, if we had followed up with them more frequently after the meetings, we would have seen that this person thought we would be doing it this way, and this person thought we would be doing it this way. So if we had said after a meeting, this is what our takeaway was that we're going to do it this way, then this person could have said, hey, I didn't see that from what we had.
So now we plan to finish every meeting with basically an overview of the meeting minutes to make sure everybody's on the same page.
So knowing now that ITS takes more time to provide you with some services that you require, moving forward, how can you try to mitigate that?
So there shouldn't, from looking forward, there shouldn't be any other services we need from them. But in the future, we're going to be more proactive and hopefully just kind of increase the pressure on them to deliver things back to us faster. Some of them were out of their control. They were internal decisions on where to put the server, and that was another person who was even outside of our scope of our project. So,
yeah. We also have every other week we meet with ITS to get that feedback of how they think we're doing and ways that we can change.
So going forward with your work with Tableau, have you guys used Source yet? I'm just wondering because in our team, like, we had an issue where we couldn't get access to a Tableau server, and it's kind of a big deal.
we have a subject matter expert on Tableau through ITS who has provided us with a Tableau server and the student licenses for it.
So actually, that goes back to the local installs too, is we have local installs of the student license Tableau that we can use with our local installs in MariaDB, or just an Excel spreadsheet you can send into it. And then once we move to that dev environment, we can use the one provided by ITS.
One more question? All right, let's thank the team.
Sure.
Hi everyone, we are the Dream Team, and the project we've been developing is Multimate. The subject that we are inside of is protein function analysis, and we'll be going over that in just a second. First, we wanted to introduce everyone that's been a part of our team, and so starting on the right.
I'm Shannon.
I'm Steve.
I'm Josh.
And I'm George, and there's also 3 members who aren't standing up here that have been a part of our team and essential to this project's development. First, we have our pair of sponsors. Paul, who's been a domain expert and provided insights into the types of users that will be using our project at the end of the term that we develop it, as well as Herbert, who has provided not only domain expertise, but as well as technical understanding to the current version of this project that exists, which has been very important, and we will go over that later. Finally, we have Professor Kaiser, who has been our project coach and has allowed our team to focus on the development and the process that our team has chosen to implement and follow, instead of possibly being overbearing on our team, which has allowed us the freedom to make some mistakes, but remain focused and produce a project so far. At this point, I'd like to hand off to Josh to go over our domain and our background.
Hey, so in our project, we are under the field of structural biology, and what our project focuses on is something called protein function analysis. This includes a lot of scary sounding vocabulary, so we're going to go over a little bit so that the rest of this presentation makes sense. So protein function analysis is basically comparing the structures of 2 proteins to find similar parts. This is done doing a process called alignment, and basically what we're doing with that is we're lining up similar elements of proteins. And the way we do this is using something called a motif. And a motif is basically a well-defined structure inside of a protein. This sounds a little bit boring, so we're going to use some pretty pictures to help kind of illustrate this. Yeah, there's a nice thing here. We have our motif in the blue. It's part of a protein called 1-RTF, and it is aligned in the green with a similar portion that was found through this alignment process, and this is in a protein called 8-GCH. So the big kind of problem statement of our project is that biology students need an easy-to-use tool that can be used to compare these protein structures and do these alignments. So when we first started, we learned that there was a desktop app called PyMol, and the RIT biology department and Dowling College helped develop a plugin for this application called ProMol. And what this plugin does is it automatically does these alignments and helps visualize them. There were a couple issues with this plugin. Notably, it ran fairly slow. It was only compatible with a very specific old version of PyMol, and it was very, very difficult to install, especially for the user base, which was biology students who aren't necessarily going to have a lot of technical expertise. So our project was to create a new software product that replaces ProMol. We want to have the same functionality, a minimal installation progress, and require little technical expertise to install and use. We also want the software that we make to be maintainable and extensible, so that if this needs to be built on more later, we won't have to face the same problem again where someone looks at this and says, hey, it's probably better off that we re-implement this from scratch. And now I'm going to transition back to George so he can talk to you guys about the requirements.
The process that we went through when we were gathering requirements was actually cyclical. We started off, because we had this PyMol, ProMol plugin set up that our sponsors were utilizing at the moment, we were able to have them give us demos of the things that they wanted us to build in the end, so that we could see the sample output and be able to see what our requirements or what our functions would be in the end. This sounds like a really easy way and a really successful way to do a project. You know, someone has an example that they can give you, and so you follow and you do the similar things. Unfortunately, among the 4 of us that are up here developing this project, none of us are exactly experts in the field of structural biology, and so designing and creating an alignment algorithm was something that we spent most of this semester, I will say, learning how to implement and learning how to understand the domain and the biology necessary to create this project. And so what we ended up doing with this cycle of requirements gathering is we were watching and learning about the field and the domain, and then going and asking clarifying questions with our sponsors. And what we ended up finding was that yes, Promul works, and there are success in using it, but the reason it's being replaced is that there are multiple workarounds implemented, as well as since the plugin of Promul was developed by biology students that were learning Python as they were writing it, there are multiple instances or situations that when you're using the plugin cause the entire application to crash. And this irregularity really struck a flag with us, and so we wanted to make sure we weren't just nailing down, this is, you know, when we provide this input, this is the output and the expected result. We wanted to nail down what are the ideal situations that the application flows are going to be taking. A specific instance of this, or 2 specific instances that we really wanted to go through with our sponsors and nail down is when you are going through a search in Promul, it actually closes the visualization window, which is misleading because you think the application has crashed, especially for people who have used it for the first time or are using it for the first time. The reason they do this is because Pymul is an expensive, memory-wise application to have running. And so they close the visualization window in order to conserve memory, which is an excellent workaround, but it's confusing to first-time users. And if you're a biology student doing a lab for the first time, reading through the directions, you're probably learning this material, and the distraction of, wait, where did that window go, is unnecessary and can hurt your understanding of a project. Another feature that we really dug in with our sponsors and had them go through, you know, what's the important information here, is the log. Every command that you are running in this program gets logged to console output that Pymul provides. Since in our re-implementation, we thought it would be messy to, you know, you clicked on this atom, and so that's the atom that we're printing to the log, or you displaying this visualization comparison, so we're going to log those RMSD values. We found also during our demos that the sponsors were scrolling back up to find some of this information. And so we really went through, and we had the sponsors actually email us, can you do these tasks they were actually going to be doing these tasks with another group. Can you go back through and highlight the sections of the log that are important to you so that we can show them to you at all times so you're not scrolling back through to find them? Or we can make them blatantly obvious in our version of the log so that if you do end up scrolling because it's 3 or 4 actions backwards, you can find them easily. And so those are 2 examples of situations where this cyclical process of requirements elicitation really benefited us. The process that we ended up choosing was Kanban, and this provided us a focus on things that we start, we want to focus on ending or completing them. And that ties in with what Steve will talk about later with deployment and how we want our deployment process to be simple and straightforward so that as we make updates in the spring going forward, we are able to push an update because something's been completed, and our deployment will refresh and be updated. Another benefit that this Kanban delivery has given us, or our Kanban process has given us, is we have a live version of our release 1 still going so that our sponsors can tweak and play with it. And we've been able to almost separate the concerns of building a backlog with getting this initial version of the project running so that as we were building our first release, we could look forward. We had an understanding of the scale of the project, but the details around these are all the collection of tasks that we are going to be doing, we didn't necessarily have the greatest picture of in the middle of the semester. Towards the second half of the semester, we ended up making, at our sponsor's request, a project punch list. So this is a rather long document detailing all of the development tasks that we have remaining for the rest of the year, so that we can use our t-shirt size estimations that we've done so far with the development tasks that we have associated with them and the time that it took to accomplish those various t-shirt sized tasks. So we can make sure that the planned releases that we have in the spring and the up-to-date versions that we are going to have in the spring, that those release dates and schedules are appropriate so that we're making sure that we're finishing our project with enough time to be able to present at the end of the year and say that we finished. At this point, I want to go ahead and transition over to Steve and Shannon for talking about the design and implementation of our project so far.
After a few meetings with our sponsors, it was pretty clear that we could take the project in one of two directions. As we mentioned, there already is a product, Promol, which is a plugin to a Python library called Pymol. We had the ability to utilize this information and just create a service on top of it with a web view to make it easy for people to access and utilize. However, some big problems with this was the fact that in order to make a request from the web browser, we would have to start up a separate instance of Promol and Pymol for each search request that was going out. Obviously, this is really computationally expensive, and there's already concerns with being able to set up these programs to begin with. However, if we took that approach, we wouldn't have to touch any of the actual alignment algorithm part, so we wouldn't have to worry too much about the domain. Our team decided that we should do a from-scratch full-stack web application. This was the best approach because we could apply clean, modern technologies to the problem, as well as being able to update Promol on the whole. Right now, there's a new file format, MMTF, that's been released by the National Protein Data Bank that currently Promol isn't able to accept. This is becoming kind of the standard format, but there's really no way to update the logic that we have in Promol right now, so it's better if we just create a new stack where we can accept those updates and bring the project as a whole into the modern, standardized technologies used within the biology community. Another great benefit of using a web application is there's no setup for our users. If it's hosted on a machine, they just go to a URL, they don't have to download anything or run it locally or worry about versioning. This is also important as different colleges have different requirements on what you can install on computers themselves, so this removes any of those needs. This is a high-level overview of how our project and our code is structured. We have a front end which takes care of the molecular visualization in its own separate repository, and then we have our back end which takes care of the requests as well as the actual alignment algorithm, as well as maintaining our database. We utilize containers to make deployments and setup incredibly easy. A little more information on the front end specifically. We're using a standard React Redux tech stack with Material UI for the styling. The biggest concern with the front end is obviously the molecular visualization. How are we going to display the superposition of two proteins on one another? There's a lot of different libraries that are available to do this visualization, so we had to really dig through and research. This is pretty challenging considering, as George said, none of us are biologists, so we don't even necessarily know the feature set to be looking for. Our sponsors were useful in this, as when we think we found a possible solution, they were more than willing to look at it and investigate and see if it was exactly matching what they were requiring. The one that we decided to go with was NGLView. We selected this because it's open source and is consistently receiving updates within the community, and it has an expansive feature set. Specifically with NGLView, you can opt into what features you want instead of being forced to get all of them out of the box. This was nice and unique to this because the other libraries that we could have used were really heavy, and for such a computationally intensive web service, you don't want to add any more loading time than necessary, and you don't want to provide newer users with more functionality than they really need. So another final reason why we picked NGLView was the National Protein Data Bank actually uses this visualization library on their website for the individual protein entries in the database. This means that if the biggest supplier of this information is utilizing this source, it'll probably stay up to date and be relevant for the next couple of years.
So our backend is built using Spring Boot. We made this choice because it's a robust application framework. It makes it very easy to create REST APIs, and it does an excellent job at abstracting SQL from our database interactions. We had considered, as Shannon and others mentioned, alternate backend frameworks, something maybe in the Python realm, right? Because our original algorithm was in Python. However, if we wanted to reuse that original code, it would have required us sticking with Promol, which reintroduces a set of limitations that were faced by Multimate's predecessor, Promol. So another big issue would have been deployments relying on having that additional piece of software running for each instance of Multimate. It's not an architecture that scales very well. But with Spring Boot, we were able to easily separate out logic into a controller, service, and data layer, where the controller layer handles all the requests, the service layer handles all business logic, and the data layer handles all database interactions. Choosing Java also gave us a very wide option, or a wide range of options for libraries to do biomolecular structural analysis, and we decided to use BioJava, which is a very powerful library used for processing biological data. It's the most complete open source protein library available in Java, and it's made it much easier to work with protein structures and to perform structural alignments. In designing our deployment strategy, we also had to consider the ways in which this tool would be run. We wanted Multimate to be an easy tool to set up, while still supporting both local installations and a dedicated server hosting deployment style. This enables an individual to run Multimate locally, or a larger organization to deploy instances of Multimate, which would be consumed by many users. Further, we acknowledge that it's likely this will be deployed on an unpredictable variety of environments. We do not want our users to bend to system requirements. We don't want them to have to configure their system in such a way that it satisfies Multimate, but rather that we should be able to deploy in a consistent and system-agnostic manner. Docker is what we decided to use for our deployments. It enables Multimate to be deployed on any environment the same way every time, so long as the system has Docker installed and provides sufficient system resources. In an ideal state, anyone can install Docker and run this tool without further system configuration. It would be as easy as a one-click deploy. Now that we've described the system architecture, I think it's valuable to understand the current flow between starting a motif search and getting back search results. A search query goes from the front end to the back end, where the controller then shapes that request and passes it off to our alignment service. This will then reach out to the database, perform each alignment, and return back to the front end the relevant set of motifs that best align. Finally, the proteins will be visualized and become interactive for the user, like you can see here. This is the end result a user might see. It's one protein, its active site superposed on another, and ultimately the user will be able to visually compare the proteins of interest against any well-defined protein with which it closely aligns. Now let's turn to Josh, who's going to continue talking about testing.
So one really interesting aspect of our project that I think makes it relatively unique is the fact that we are doing a re-implementation. So one of the things that we have to consider is how we're going to make sure that we're doing the same thing that the other version of the product did. And the way we're going to do this is through user testing. Basically, we have our deployed version that the stakeholders use, and we're going to also be using that to track certain metrics like time to install and time to view search results, which is what we're going to have students try and do in order to make sure that it is the expected experience. Next up, I'm going to go and cover some risks. So the big risk that we had was our alignment algorithm. It was a very difficult part of the project, and the fact that we're re-implementing this project from scratch means we have to write this on our own. This was very difficult and very scary, but we knew that we could do it and ended up mitigating this risk. The way we did that was first by identifying that it was a very important part of the project. This was a non-negotiable feature. It's like having this project without the alignment algorithm is like having Facebook without friends. Doesn't make sense. The consequences of having this would be pretty bad. And so our mitigation was to learn more about the domain, talk with the stakeholders, and explore the technology and make sure that we could do this. Otherwise, we would have to explore building something in the Python realm. And we ended up finding that we didn't have to do that, which was pretty great. And before we go to questions, just want to take a moment to acknowledge some of the funding efforts that have gone into this project, the Basil Project and SBEVSL, as well as a bunch of grants over here and RIT and Dowling College. Any questions?
Do you guys think it's possible we might be neglecting methodology a little bit because you guys are kind of like a power group as far as individual skill? I think that towards the beginning of the semester, I would certainly agree with that assessment. When you have high-functioning individuals on your team, it's really easy to want to charge forward into the development of the project and proceed from there and kind of we'll handle it as it comes up. One of our sponsors, when our sponsors encouraged us to make the punch list, and it's important that you all understand the releases that you have planned and the remainder of the project that you are expecting to associate with certain dates. That definitely provided us with a step back and possibly a humbling moment to be like, wow, there is still a lot of this project. The fact that we can touch and spin a protein is nice, or an active site is nice. But yeah, there's definitely been a lot of process that we've been recovering from in the second half of the semester going into next year.
So if you really guys did a lot pretty well, what did you not do so well? Is there anything looking back, like moving forward, any changes you made, or mistakes you made, or
Yeah, so originally we actually selected a library called Lightmole to do the molecular visualization. And the reason that we changed it about halfway through was because, one, it was really heavyweight. It was taking a significant visual amount of time to load, as well as it didn't have the same accessibility and openness into the actual alignment and superposition algorithms that we needed to run to align the actual proteins. So that's when we had to go back and redo some more research and then reselect NGL-View. Luckily, they're both relatively easy, open tools to use, so it didn't take too long to physically make the change. It was more of trying to track down a visualization library that was going to have exactly what we were looking for.
Yeah, so I have a question on kind of follow up after it. So you said you guys are making queries to the National Protein Database and whatnot.
Sure.
So I know this because my girlfriend's in bioinformatics and whatnot, but I know that there's the three main databases, one in the United States, one in Europe, and one in Asia, and they all have their individual pieces of the data that's spread out, and you can go to them and make queries on them, and it will choose where it needs to go. But those queries can take forever. And I know that because I've watched her sit there and put her computer out and let it go for 30 minutes without getting a response. So how are you intending to handle that? Because not only do you have the time of the visualization, but you also have the time of the query itself.
Sure. So I presume the kind of queries your girlfriend is running in that scenario are more advanced than what we're doing. She's probably running things that are doing really advanced filters on these proteins. What we're doing is we know which proteins we seek to compare against well-defined proteins. So the user enters the four-letter identifier, HECH or something. Because we're only querying that specific structure or the set of specific structures being asked for, there's no need to perform a 30-minute query. It's almost instantaneous. Yeah.
So what would your acceptance criteria for the algorithm, the superposition algorithm itself? You talked a little bit about the acceptance criteria for the product, but kind of zeroing in more on like performance, visualization expectations, that kind of thing.
Yeah, so what we ended up doing with that was we installed a local version of Promol itself, and what we were told by our sponsors was it would probably be very, very difficult and tedious to go through an exhaustive list of all motifs possible. So we were reducing that to a smaller set of motifs to test with at first. And so we created a set of 4 or 5. And what we did is basically compare those alignments to the ones in Promol. And we were checking to see essentially, are we getting the same items in our alignment? And that was kind of how we did that. And then also we checked with our sponsors when we showed them that to make sure, for sure, that this was exactly what they were looking for, and they seemed pleased. So.
Let's thank the team.
Hello everyone, we are the Tioga Tigers. I'm Stephen Malmgren.
I'm Mars Valentine.
Jeff Godowitz.
Ryan Meharada.
And today we'll be talking to you about the Tioga Taekwondo Student Management System. So to start off, I'd like to give you an overview of the project in its current state, as well as some of the problems that it aims to solve. So the project is a software application that's used inside of Paul's Taekwondo Studio, and it mainly resolves issues around tracking student information. The Taekwondo Studio will have a lot of students. Each of these have several data points that need to be updated expediently as the instructors are trying to teach the classes out on the floor. Our goals will be to work with this existing system, continue to expand on it to increase its utility, and also optimize some of its existing functionality. So to give you an overview of the technologies that are used, we have a local Windows machine hosting this application, and it's connected to by Windows tablets that are out on the floor. The application itself is a model view controller architecture. It uses a SQLite 3 database, a Django REST API, and an AngularJS front end. Now, you'll note AngularJS is quite outdated. This application was inherited. This was done by a previous RIT senior project team. The front end, we determined, was not worth the effort put in to refactor, considering it's still able to provide the service that is needed out in the facility. And considering the service is fully used as of now, it was determined that it wouldn't be worth refactoring.
Now, diving into our process, specifically how we elicited our requirements, during a weekly basis, during our weekly sponsor meetings, we would have open discussions regarding possible features and requirements related to the application. And during these conversations, we would record any decisions that we made regarding the requirements, as well as any other possible impactful decision that we have made. Following each meeting, we would send out the meeting minutes that included these decisions. This way we could confirm with our coach and our sponsor regarding the decisions that were made and make sure that there was no misunderstandings or miscommunications regarding anything that was discussed. This open dialogue allowed us to get quick and effective questions answered, which allowed us to move very proactively through the project. In regards to our development methodology, we incorporated portions of the Scrum methodology into our process in regards to the needs of a senior project group. Our process was iterative in nature, as is Scrum, and this was able to handle our evolving requirements, as this was an inherited system. So we were more providing additional functionality to the system rather than rewriting it as a whole. And with this in mind, the evolving requirements became much more handleable. Each of these sprints were broken up into 2-week increments, and at the beginning of each sprint, we would hold a team sprint planning meeting to go over the user stories that we would incorporate into our current sprint, as well as do any backlog grooming that was necessary to update any user stories or create new ones due to discussions made during our meetings. This high customer involvement, as I said before, helped to give quick and effective feedback so that we could move along with our project effectively and quickly.
So going more into our scheduling and estimation process, so we followed a top-down approach when breaking down our requirements and relatively large features. So we took each feature and then really just broke it down and looking at what we would need to break that down further into tasks that we would be able to handle within a single sprint. So to do that estimation process, then we used planning poker. So we took the smallest and largest stories and assigned those values of 1 and 13 respectively. And we looked at the rest of the stories and then assigned them relative positioning according to those benchmarks. And that was following a Fibonacci sequence, and most of our stories ended up falling in the 3 to 8 range. So our idea initially was that an 8-point story would take one person a sprint to complete. So that was our initial estimation process. And once we had the list of user stories and once those were pointed, then we grouped those into epics. These epics were largely mapped to the initial features that we identified. So it's a good way to organize the user stories. Then we knew that when we were looking at the list of epics that we still had left to complete, then that was largely the major functionality directly from the requirements. And then based on the regular check-ins that we had with our sponsor, then we were able to prioritize those epics and checking in regularly during our meetings to make sure that our priorities were still clear, and kept those stories organized into a backlog. So we used Trello for our maintenance of our backlog, of both our product backlog and our sprint backlog. So we really made sure that our Trello was kept up to date with updated priorities. So whenever a story changed priority or status, then we had to make sure to update it in the Trello, and that really helped to ensure that we were accurately reflecting the project's priorities. And then our visual design creation. So we spent a lot of this semester doing wireframing and really looking at the UI and UX design for the implementation for the features that we'll be implementing later on next semester. So when we were eliciting our requirements process, and we really wanted to, within those user stories, capture some of the user flows and all of the possible ways that the user would be able to interact with the system. And then as we were synthesizing this information, we held team whiteboarding sessions. So those were very informal meetings intended to brainstorm as many layouts and possible workflows as possible so we could get some good ideas going. And that was really making sure that we got everybody's input, making sure that all ideas were heard. That was really helpful in figuring out the direction we wanted to go in for our layouts, and also dispelling any misunderstandings that anybody might have had about the requirements or any of the features. So based on that initial whiteboarding session, there would usually be 1 or 2 people that would take that whiteboard wireframe and then convert it into a high-fidelity wireframe. And then when that was finished, then we would present it to the sponsor. We had pretty quick turnaround for this. Usually within a week, we would have a wireframe available for the sponsor to start providing feedback on. From that, we would just continue iterating on that wireframe and continue to incorporate sponsor and team feedback until we were confident that we had a high fidelity wireframe that we could be satisfied with. And at that point, then we implemented it into a prototype in the system so the customer could actually start interacting with it. So this is an example of one of the first features that we implemented for the semester. So this was the editing belt and stripe process. So currently, the way that it works in the current system, then instructors have to go through many levels of pages and screens in order to change a single student's belt. So for instance, during a promotion test, they would have to be walking around and for each student, go to the student's profile and then click several links in order to change that student's belt. So you can imagine as they're walking around the studio, then they're spending a lot of time doing this. So we really wanted to make this process as efficient and effective for the instructors as possible, so they can really be spending as much time as they can with their students and not being frustrated by the application. So you can see that we have a list of basic functionalities that the instructors will be focused on as they're conducting their classes in the studio. So the idea is that they can quickly switch between screens. So if they need to go between editing belts for a student and then adding students to the test sheet, that makes it really easy. Switching between the screens process is very simple. And for editing a belt, then with this view, we redid the implementation so they only need to stay on one view. And this way they can select a single belt and then select multiple students that they want to assign that belt to. So they don't have to worry about going through multiple screens just to assign a belt to students. So this really improves the process of the instructors assigning a belt and stripes. And then you can see that this is our implementation of that wireframe. So this is implementation that we finished this semester. So this is taking those key elements from the wireframe and incorporating those directly into the system. So you can see that we have the menu and the sidebar, and this was actually some feedback that we received during the implementation of the prototype. We found that it was difficult to see which belt was selected, so we were able to incorporate that feedback directly from the sponsor and make sure that made it into our prototype, and now we're able to see which belt is selected a lot easier.
Okay, and that leads us to our implementation. So the version control system that we used was GitLab, hosted by the College of Engineering. You might find that our branching structure is very similar to others that you may have seen. We use an agile code review process. So essentially, whenever we have a feature branch for each user story, once that feature branch is complete, that is then sent out to the team for code review. Once the team decides that it is ready for staging, it is then staged into a separate branch. The branch is then used for interaction by the sponsor for acceptance testing before it is integrated into the project, and we can move forward with additional features. For the implementation, we did strive to meet the existing standards for the previous team. So for testing, we did end up using, for UI testing, the same framework that the previous team used, Protractor, which is a JavaScript-based UI testing framework based on Selenium. To base our testing, we created activity flows that describe the flow through each of the user stories that we implemented. So those would also inform the design documents that we created and the wireframes to make sure that they fit the sponsor's needs. And lastly, as I mentioned before, the staging environment was used for acceptance testing.
To keep an eye on how the project was progressing, we chose a couple metrics that we thought would give us the most value, both internally for the team and for the coach and sponsor. Given our design methodology, we chose sprint velocity so that we could have an idea of exactly how our project was progressing. Initially, our sprints had varying completion for the points, considering we were working with an existing application, getting familiar with it, and ultimately getting deployments out, made for some variation within the points that we received. The next metric that we chose was the defect density. The defect density is a measure of the number of defects per user story released. This gives us an idea of the quality of the product and also might give us an indication where some issues in the system might lie if there's a correlation between certain user stories and defects. The user story dependency chain is the next metric that we chose to record. This is a structure that allows us to see the prerequisites for any user story, which very much helps when it comes to identifying a critical path and also giving you an idea of exactly how long a certain user story might take. I'll show you an example of our Google Calendar user story dependency chain. So this allows us to quickly identify exactly how many other user stories must be complete given any individual user story. And this is very useful in dialogues with the project coach or sponsor in identifying exactly how long a certain requirement will take.
Looking at our risk management, on a weekly basis, we would include any risks that we are currently facing within our 4UP charts that we would then present at our weekly sponsor meetings. This way, we were able to provide transparency and concerns that we had regarding the project and moving forward. We also created risk mitigation strategies for each of these risks as they were active risks that we felt that had a fairly high probability of encountering. With that in mind, we wanted to mitigate the impact of these risks where we could. Looking at a couple examples, one being outdated documentation causing confusion. If this was to happen, it could cause some confusion with the sponsor and the coach if they were to view our project artifacts without them being actively updated. They could see some discrepancies regarding decisions that were made during meetings and things like that nature. To mitigate this, we set aside time within our weekly team meetings to update this documentation when needed. The second risk being Google Calendar, unknowns and volatility. In regards to this, if Google Calendar provided us with a bunch of unknowns that could cause issues in our estimating. To mitigate this, we created a user story and labeled it as a spike to set aside some time to look into the possibilities of the integration with Google Calendar. And on the side of the volatility of the API, we had a little bit of concern that in the future the Google API might change, and if this was to occur, some of the features related to Google Calendar in the application would cease to work properly. And to mitigate this, we decided to implement Google Calendar, or plan to implement Google Calendar in a modular way, so that if the API was to change and cause that feature to fail, it wouldn't break the entire application. Moving on to our current progress and what we've completed in respect to user stories. As we have identified, this was an inherited project, and we had some difficulties getting it up and running initially, but we were eventually successful with that and continued to provide some useful features in the form of streamlining the edit belt and stripe, as we discussed earlier, as well as creating one-time events for things like promotional test events to streamline the process within the dojo for Paul. As well as tuition tracking for a business incentive to identify students that have paid and have not paid for a given month, as well as the Google Calendar integration, as we stated before.
So lessons learned. We did discover over the course of the semester that we did have a very good team synergy. We were able to communicate well, and everyone was very active in team meetings. So that was a positive side. What didn't go well was, obviously, as was mentioned, we had some issues launching the legacy product, and that led to some problems with our initial effort estimations due to we had some unrealistic expectations of how long things would take, and so we underestimated the length of certain user stories. Over the course of the semester, we did improve in requirement solicitation and elaboration, which was a big plus. So for next semester, since this semester we primarily focused on planning activities, next semester will be a lot more focused on the feature delivery. So features such as incentive points, bulk import, and Google Calendar integration, as mentioned.
Does anybody have any questions?
Yeah, so being embedded in the inherited project and whatnot, where in the beginning you had said, oh, we chose not to refactor the UI and whatnot, and you said you spent a lot of time on wireframes and whatnot. Was that on new features, or was that on things that already existed that?
So it's a combination of both. For example, the editing belt and stripe functionality that was previously implemented, so the back-end functionality was there. But through the use of the application, then our sponsor found that the instructors were having a lot of trouble navigating their way through that, and it resulted in a lot of times, those belts and stripes not being awarded through the system, so it resulted in a lot of inaccurate information. So that was a case that we identified as being like a very high priority for remodeling the user experience, so redesigning the front end. So for that case, then we left the back-end implementations the way that everything works in the database alone, but that was really focused on making sure that the front-end experience was something that the instructors were going to be able to use more effectively.
Given your difficulties getting the product up and running, kind of what's your plan for when you hand this off back to the stakeholders so that doesn't happen
So within the README documentation, they actually provided a very helpful step-by-step on how to get the project running, which initially we thought this was going to be beautiful and it was well documented. But as we went through and tried to actually get it running, we realized that it was packages that were out of date. And because it was in a production build, all the files were minified, and it was hard to kind of find where the issue was. So moving forward, we're going to update that README with any of the additional steps that we had to take to get it up and running, and ensure that all the packages are updated as we hand it off to the next team.
From the five metrics that you identified, to what degree have you been measuring how helpful have they been?
I'd say that the user dependency chain, measuring that metric has been really helpful in figuring out exactly which stories we'll need to tackle. For example, then we showed that the Google Calendar dependency chain, that was a relatively large, and we counted the Google Calendar feature as an epic, and a lot of those stories ended up, through mapping the dependency chain, we found that a lot of those stories were linked. So in order to, initially the way we had it, in order to get to our last Google Calendar story, we would need to complete, I think it was like 10 or 12 other stories. So that was really a sign that we needed to be looking at that more carefully. And so we were able to look at the possible implementation of Google Calendar and break those down to reach the shorter dependency chain of 5. So that means that we'd only 4 other stories would need to be completed to reach that 5th story, which is a lot better place than we were in from looking at 12. In which case we would pretty much have to start that Google Calendar implementation now if we wanted to be able to complete that 12th story.
I know in this domain there's often like a lack of technical experience or knowledge to the customers in particular. You guys went into that. In particular, how did you solve those issues you did?
Our sponsor is actually quite experienced with the processes of engineering and helping out with kind of eliciting requirements and working closely with us. So we haven't really ran into any issues with a disconnect in the software side. With regards to outdated technologies, we did have to provide some more information just to what's outdated and what it would cost to update it. But that was really the only place where we had to provide additional information.
I think as far as like the user experience goes, then the primary users would be, first of all, instructors as they're walking around the studio and doing things like checking in students. So for that, we would really want to make sure that that anything that they needed to use was made as clear as possible. The buttons were clearly labeled, so there wouldn't be any confusion, especially if they were unfamiliar. Might be unfamiliar with dealing with similar technologies to this. So that's really going to be a key focus going forward, is making sure that improving the user experience to ensure that it's easy for students as young as 6 years old to be able to check themselves in, for example.
Quick follow-up to that. Have you guys, how big is the student base? Do you know how big the community is at all?
Defer to Paul for that.
75 to 100 students.
Say that again?
75 to 100 students.
Good. Have you guys thought at all about scalability as the school itself grows, or if you market this to other studios?
So that's kind of included in our bulk import functionality we have planned for next semester. So next semester plans include the ability to scale this out to other schools. So then if the school wanted to implement a version of the system, then it would be easy for them to just upload all of their student data really quickly. So the bulk import functionality will be a big role in that, and making sure that if another studio does decide to implement this, then they'll be able to get up and running relatively easily.
Let's thank the team.
All right. So we're Core Sigma. I'm John, team coordinator. This is Ben, website coordinator. Daniil, our sponsor communicator, and Brett, our scribe. Also the most professional looking one out of all of us today. Yeah, so we've been working with Two Sigma's Beaker X, and yeah. So this is just a quick overview of what our presentation is going to be like. We'll start off with just introducing what everything is today, and go into what our goals are, what Two Sigma presented us with, our methodology, what we found in our research, proof of concept talk, as well as risk reflection, and we'll finish up with questions. So to start off, let's introduce Beaker X. It's developed by Two Sigma. If you've never heard of them, they're a hedge fund that uses a variety of technological methods, including AI, machine learning, distributed computing for its trading strategies. They're based in New York City. Yeah. And Beaker X provides a collection of kernels and extensions that provide JVM support, interactive plots, interactive tables, and more. What this extension does is it allows for polyglot auto-translation, allowing you to access multiple languages in the same notebook and communicate with them. But in order to understand Beaker X, you have to understand what it's an extension to, which is Jupyter. So Jupyter is developed by Project Jupyter and it utilizes virtual notebooks that contain live code, interactive graphs, visualizations of data, and so forth. The key difference between Beaker X and Jupyter is the fact that the key difference between Jupyter and Beaker X is the fact that that when Jupyter, a single language is tied to a single notebook. Notebooks can be compiled to be set to run in real time, meaning that any live code that you add with the interactive graphs will continuously be added to it. So these notebooks can be exported and shared with others to be imported in other people's local Jupyter clients. And both Jupyter and Beaker X are open source projects, meaning that you can go to their GitHub repos right now, download it, and set up Jupyter and Beaker X on your client. So many companies use Jupyter, such as Google, Microsoft, IBM, Anaconda, SoundCloud, and so forth. And with a basic introduction of what Jupyter and Beaker X are, I'm going to pass this off to Brett, who will introduce what Two Sigma brought to us.
So this brings us to one of the existing issues with Beaker X, and the reason why Two Sigma actually brought this project to RIT in the first place. In short, the JSON-based implementation is not optimal. At a very high level, you have data being sent as JSON objects, and that involves a lot of serialization, deserialization, and so on. And it basically takes a huge amount of time to do this. As a result, the users have to limit their data sets. And as we mentioned, Jupyter and Beaker X are used for data science. So kind of forcing your users to limit their data sets is not ideal. Here's like a more in-depth look at the process of auto-translation. In this example, we have a Jupyter notebook configured with one JVM language, and we're writing code within that notebook for a different JVM language. So you have the notebook cell, which is executed, and that is passed to the appropriate kernel, which does come with Beaker X. The result of that is being read by the Beaker X client, which serializes it, sends it to the Beaker X object. Then it's deserialized and processed and prepared for to send back to the original notebook. So heading into the semester, we had a number of focus points. Our primary goal was to research and find a solution to this problem they're having. In order to do that, we had to first develop an understanding of the existing Beaker X code base. Beaker X comes with a lot of different features, and we're kind of honing in on just the auto-translation. So we have to sort of analyze the subsystems and figure out which parts are we touching and which parts are we leaving alone. Eventually, we would have to replace the current auto-translation feature with whatever we found. Additionally, we would have to provide proof that we made the right choice. So that would involve benchmarking, performance and scalability, and so on.
So there are a few different technologies that we're using while working on improving BeakerX. Everything's based around Jupyter and BeakerX. Mostly the implementation is for BeakerX itself. The old implementation used Py4j, which allows Python to kind of communicate with Java. And it uses serialized JSON in order to pass data between languages. This worked well, but Py4j uses sockets to communicate data, and JSON is human readable as opposed to machine readable, which makes it slower. The goal of this project is to use something like Apache Plasma, which is like an in-memory data store, as opposed to sockets, so different programming languages can access the data in memory faster. We're also going to be using something like Arrow or Flat Buffer, which are serialization technologies that are optimized for speed and efficiency as opposed to human readability. We're using Slack for communication as well as having different channels for research. We're using Trello to keep track of sprints, meeting notes, and other kinds of organized information. And for Git, since BeakerX is an open source project, we're working off of a fork and are making pull requests as we make contributions. For the project, we're following a waterfall model. We're starting out by understanding what BeakerX is, what it's about, what kind of functionality it has, and what needs to be improved. We did spend a lot of time researching, learning how the repository was structured, all the subsystems, and how it actually works in order to figure out what needs to be changed. We researched different technologies like Apache Plasma, Apache Arrow, flat buffers, and whatnot in order to see what would be a good fit for the project. After learning how to use them, we're starting on a proof of concept which will hopefully lead us into an implementation.
So, a bit more into detail of why we decided to use the waterfall for our methodology. Because a lot of the technology involved with this project is pretty new, there's not a lot of documentation on how to properly implement it, what kind of use cases have there been. Most of it has been off of projects that Apache has collaborated with third parties. So it definitely took us a long period of time to just understand what we're looking for, what things that we know exist that we're not sure how to implement, what things that we're just not aware of that we need to do further research. And based on that, we decided not to use rapidly iterative builds, because there isn't really much advantage to using that when we don't really have the concrete scope available to us in the initial phase. Instead, we decided to opt in for bi-weekly sprints, where we would sit down, work through what kind of information we need to be researching, what kind of information we have to elicit from our sponsors, and other work-related tasks. And we did all of this using essentially a Kanban board. We utilized Trello and set up essentially grouped sprints, where for each sprint we would specify information about how many story points are assigned to the assignment, labels for status, so if we need information from sponsors, if we need information from a teammate, from our corporate sponsors. And we used Fibonacci story points to do the story points. And if we found that a certain task would reach more of levels of an epic, we would break it down further into more manageable chunks.
So So delving deep into our research findings, the majority of the semester, what the semester was spent on. So the main solution that we're following, that 2 Sigma presented us with, is Apache Arrow. Apache Arrow is an open source project for common cross-language and memory data formats. And it's a very new technology. It's only at release 0.11 at the moment, and as a result, there's not much documentation out there for it. But every language connected to, or every technology connected to a project may have to create their own memory format, where an implementation, or actually which implementation of this own memory format would significantly increase time and computational power with serialization. But with Apache Arrow, time and computation power required to convert one language to another is greatly reduced, and being able to utilize the same memory format makes Apache Arrow lightweight, which lowers the overhead for data scientists. One requirement asked of us was to find a technology more suitable for large amounts of data, or big data, which the current JSON implementation is not suitable for. Apache Arrow offers a fair amount of tools that are theoretically far more efficient than JSON, and we'll be going into it after just a quick high-level look at a project with and without Apache Arrow. So this chart is sort of just a quick representation of a project with and without Arrow. Without it, technologies involved not using Arrow may need to create their own implementation of serialization, and this takes up development time. Or the alternative is that you can use JSON, which, as Ben stated before, is slow largely because JSON makes data human readable rather than machine readable. So utilizing Apache Arrow, Arrow serialized formatted memory can be shared across the different technologies.
So yeah, a lot of our approach towards tackling our problem is kind of two-pronged. The first issue is finding a better way to access data, which we are trying to solve with the Plasma data object. Plasma is very convenient if it is possible to implement, because instead of having data constantly be moved around from module to module, from the extension back into the notebook, or whatever other applications that might arise, it all stores it at a single location, and it feeds the information of where said buffer is to the other clients using something called ZMQ. So Plasma plus Arrow also gives us the Plasma Store object, and that allows us to have more or less a central repository where we can always be looking for the information that we need. And the store creates objects to be stored in Plasma by allocating a certain buffer size to it, which can be amended. And as soon as the information is sealed, it becomes immutable and can be only read by different processes. The second approach that we're using to tackle our issue is serialization, which we are trying to cover with using flat buffers. Flat buffers provide a cross-platform serialization library for many different languages, many of which that are in the scope of our task, and it essentially creates buffers in a hierarchical data in a flat binary buffer without need to parse and unpack. So as soon as you're trying to locate certain information, you don't actually have to deserialize the information to understand if this is the data you're looking for or not. It could be done at a much greater speed, which improves search and other capabilities. It has a very tiny amount of code. It's very small, which means that there isn't a lot of resources that you need to use for it. In addition to flat buffers, we're also looking for tailored solutions towards serialization. One size fits all is not really what we're trying to go for. We're trying to make sure that we can for the major languages that we are targeting, that we provide tailored solutions in order to make sure that every single component and language is covered with its own unique, more optimized way of delivering data.
So we've finished up research and have spent the last couple of weeks working on our proof of concept. We're working on it in order to make sure that we understand the libraries that we're using before going forward with an implementation. We're going to be using the proof of concept to compare performance to make sure that we are actually getting the performance improvements we want compared to JSON and Py4j. We have hit a few roadblocks while implementing this. We did want to get it done by the end of the semester, but because Plasma is such an early, such a bleeding edge technology, Java libraries, the Plasma Java libraries are missing a lot of features that other languages have, and are overall very limited. There's missing documentation online, which makes research more difficult. Figuring out what's going wrong is more difficult. For instance, we had trouble getting Java to interface with the Java native interface to work with Plasma's C++ libraries. And now we're running into issues where even using the Plasma sample code from Apache, we're running into exceptions that we can't quite solve yet. We're hoping that this is just because it's in beta and we'll be able to fix this pretty easily. But otherwise, the proof of concept is pretty much almost done. The goal is to successfully transfer 1 byte of data. Once we can get that going, we could work on a stream of data that could ultimately be a stream of serialized bytes communicating between languages. Once the POC is implemented, we'll be ready for performance testing. We'll be able to see if the library works, the performance is as good as we want it to be.
So in terms of risks that we're encountering, we've already mentioned a decent amount of them. Beta status of Apache Arrow and associated technologies do propose a issue, as we do not know that if there will be any changes to the API that might break our workflow. There's also the issue of scope creep. Our task was essentially, in layman's terms, to make BCorrect's auto-translation faster. That can be done in numerous ways, and we've decided to stick with the things that we've researched, namely zero copy memory storage and better serialization tactics. But it is possible that new requirements arise that we may have missed due to the complexity of the system that we would have to address in the future. Also, there's the issue of making sure that the technologies that we did decide to use are actually compatible with the current design of the BCorrect's project. We're not trying to reinvent BCorrect's. We're trying to make a small but important addition into the way that it processes data, and we're not trying to rewrite the messaging system that they have via ZMQ or introduce other variables that BCorrect's and 2 Sigma are just not going to support. And other than that, yeah, those are the predominant risks that we have, but we think that we have a chance.
So, looking back on the semester, there's a couple of takeaways. First is progress is kind of not as clear as we would like it to be. When we have a large portion of a project dedicated to research, it's hard to quantify that into, how well are we doing? Are we behind in things? Are we okay? Also, exploring different options as far as our solution goes. We don't want to start coding something right away, find a better solution, and then say, what now? Do we have technical debt? Do we have to go back and change that? Do we keep moving forward? Overall, we think we've made good progress. We have fairly consistent meetings Monday through Thursday, and as a team, we have good synergy together. Thankfully, the client is satisfied with our findings so far, but we still have some plans to move forward with the project next semester.
And I guess to finish it off, in regards to going forward next semester, as we mentioned, we still have a proof of concept underway, and while not presentable at the moment, the base design of the proof of concept is pretty much 90% done. And theoretically speaking, once we get past this hurdle, once we get back next semester, we should be able to finish this benchmark right away. So within the first week or two of the semester, we should be able to present our sponsors with something that they could use to at least measure whether or not we have provided the right solution. And following that, we'll be entering our implementation phase, which will tackle how we actually implement our proof of concept into BeakerX architecture. And we're very hopeful about our results in the coming semester, so be prepared for the sequel, Core Sigma Electric Boogaloo.
Any questions? Yes.
So what sorts of mitigation strategies or backup plans do you have in case Apache Arrow don't entirely work out?
We can probably, so if using Apache Arrow on its own turns out to be more trouble than it's worth and ends up not being the right solution, we could still borrow the components that it uses, such as plasma and flat buffers, because these are all individual projects and they're modularized enough that we don't really need Apache Arrow for it, but Apache Arrow definitely helps a lot by making the necessary bridges between languages to make the process easier. But if it doesn't work out, we still have the technologies that it's based on, and we could still make significant improvements in speed through serialization and zero copy memory.
So at the beginning you had mentioned that this was an open source project. Is there an open ticket to fix the performance issue that is already on the project? Has anybody attempted it already, and have you looked into what other people have done? Or are you just, is this kind of the company doing it without pushing it out to the public yet so that you guys have your best?
So there is actually a ticket specifically for our task. It's it's mentioned throughout BeakerX documentation that they've been looking for someone to implement this. We looked through the ticket. There was one person that seems to have found some sort of solution, or at least an idea of how to get there using ZMQs. But we don't really, we're not working with anyone else except for our sponsors.
No other questions? Okay, let's thank the team.